Hello, everyone, and welcome to the webinar. This is Sydney speaking, and today's webinar will be dealing with the new operation that we've introduced in the beginning of 2015 of the whole wizard recognition. There have been certain questions that have come up ever since we've introduced it, so I'd like to go over certain points and show you also how you can actually manipulate the process as well. Some of it will be a little technical, but it won't be hard to follow, and there's always a support team that will be able to help you out later on as well. So actually, let's get into the webinar itself. I will share my screen as well. Now, let's first start with this part. Now, what I'm going to do with this part, I'm actually going to start by defining a home position and doing all the things that are necessary to do to get this part started off. In fact, do some machining around it as well, and then we'll deal with the whole wizard. Now, note, whole wizard operation is specifically meant for parts in SolidWorks that were created in SolidWorks using the whole wizard feature of SolidWorks. For example, if we take a look at my my SolidWorks tree at the manager at the left-hand side, you can see that we have holes over here. For instance, it's count the bore hole. This is an actual function of the SolidWorks feature as shown over here, called whole wizard. These are holes that we created for whole wizard, and this process is specifically for those type of holes. Now, one more note I'd like to also point out is this webinar in itself, I'll be using the new version that will be coming out in about another 3 weeks, SolidCAM 2015 Service Pack 3, and there may be certain things you may notice over here that do not exist yet on what you have, and I'll point them out to you as well, and I'll also explain why they are that way, so that when you get Service Pack 3, you'll know exactly what's going on. And it doesn't necessarily have to do with the whole wizard itself. So let's actually get started. So what I'd like to do is take this part, machine it out, and then drill out these holes or machine these holes using the whole wizard operation. So first we'll start a new project, new milling project, and I'll just click on OK. And we have to create our home position. Now, before I go any further, I'd like to also point out one of the things you'll notice that when you do get Service Pack 3, note that I have my machine over here, excuse me, I have my controller over here. You'll also note that in my iMachining data, that information is there already as well. In other words, we have a new settings inside SolidCAM that will automatically put a specific iMachining database based on the machine that you've chosen over here. And I'll show you a little later on in the webinar exactly what that's found. But that's one of the things that's coming up in Service Pack 3. Okay, let's get back to what we need to do now. Okay, so we'll create our home position. I'm just going to create it at the top over here, which is I have it set at the center of the part itself, as shown over there. And I'll accept that. Now my stock is already defined. In this particular case, I have a stock that's just a box around the part. I don't have round stock for some reason. This is what was available to me from the manufacturer, so I'm using this type of stock to work with. Okay, we'll just continue on now and just click on OK. And before I start my whole wizard operation, I want to do some machining on it. For example, I'd like to do a face mill operation on top. So I'll go to my 2.5D face mill operation. I'll choose my geometry. In this case, I'll use my target, and I'll offset my target boundaries to 2 millimeters on each side because that's my stock itself. And you'll note that I'm also working with a template already. So my tool is already defined inside over here. And my technology, I'm already working with this spiral technology. Okay, now note when I click on Save and Calculate, you'll see that you'll note there's a toolpath that already appears on the part itself. That's also something that's in Service Pack 3 that will automatically load the toolpath, and we have settings for that as well. Okay, now next I'd like to mill out all of these pockets that are inside here, everything that's around, and also the excess material that's on the outside. So what better way to do that than using iMachining 3D? So I'll go to iMachining 3D, and I'll just choose my tool. I'm going to create a tool, say an end mill that's a 20 millimeters in diameter. My R-bar diameter, I'm just going to have a little bit of, a little undersize. And I have my total length of this at 120. Outside the holder, I'll have it at 70. And my shoulder length, I'll have that at 40, as well as my cutting length will also be 40. Using 3 flutes, having a tool with 3 flutes. Now remember, my machine was already chosen inside automatically chosen my CAM part, as well as my material. Okay, I'm going to use not 3D general, but 3D prismatic, as this is a prismatic part. Straight walls going up, no problem. Levels, I'll leave it exactly the way it is. My technology wizard is all set. And in my technology, I can leave everything the way it is. Note there's no scalp control over here because we're working on a prismatic part. I'm just going to do Save and Calculate, and we'll get the iMachining, 3D iMachining toolpath to machine out all of the rough material over here. Do all my roughing on this part all in one simple operation. Okay, let the calculation finish. Will be done in a moment. And as you can see, you can also see that the toolpath is being shown automatically after we calculate. Okay. Now what I'd like to do is start working on these holes. So a little bit about the whole wizard process. The whole wizard process is actually based on a machining process, okay, which is automatically installed with the program. That machining process is installed in the program, so you don't have to worry about creating one. It's there already. Now, how does it know what machining process to use for this? Well, if I open up my machine, okay, in this particular case, I have my G-milling 3X. If I open it up and go to my working style, click on General, you'll note that it's automatically directing it to a specific machining process. I can open it up and take a different machining process, but it has to be one that's specifically for the process, for the whole wizard process. Okay, and we'll talk about a little bit more about that a little later on. Okay, so we see exactly where it's getting its information from. Okay, so now let's start with the process itself. Whole wizard process, and let's first start with counterbore. Okay, now as you see, we have counterbore holes over here, and we also have counterbore holes over here. Now, I chose counterbore. What happens if I accidentally choose a different hole? So I'm going to choose this countersink hole over here. Well, in SolidCAM 2 Service Pack 3, you'll get a notification that says, please pick a counterbore hole. This is one of the questions that always came up. So we added this to Service Pack 3. That'll notify you that you've chosen a wrong hole. Also, when we choose the counterbore hole, by the time Service Pack 3 comes out, you'll also have a notification here on the bottom that says pick counterbore hole. Okay, now that I've mentioned that, let's actually start the process. Okay, so I'll click on my counterbore hole, and notice on the side over here, we have wizard chosen with pattern. So if any holes was created off of that wizard with a pattern, the pattern will also be chosen. I clicked on that hole, and as you can see, it took the 3 holes that were created with the counterbore as well as the pattern itself. Okay. Now, before I continue, you'll note that there's a little button over here called dump. What is this dump button? This dump button will actually, if you click on it, by the way, this dump button is also added in SP3. This dump button will actually give you all of the information that SolidWorks can give you on these particular holes that you've chosen. For instance, if I click on it, you'll get a text file, and it tells you that it's a counterbore hole. This is all the information from SolidWorks. Now, since it's a counterbore diameter, it'll have a value for the counterbore. Counterbore depth, it has a value for the counterbore. Countersink angle, well, it's not a countersink, and there is no countersink, so it gives you a 0 value. So everything that has value has to do with that particular hole. For instance, this particular has a mid countersink diameter of 19, and it's mentioned over there. Mid countersink angle over there as well. And all the information that can be given to you that is known to SolidWorks on this particular hole will be printed out on this particular sheet. This is more for information. Okay. Getting back to what we need to do now, let's just click on OK. And our operations were created. Okay, continuing on to the next set. Again, counterbore. Now, I like to leave my toolpath showing. This way I know which ones I've chosen already. Okay, so I'll click on that one over there. And it is a counterbore hole, so therefore it'll appear over here, and we'll accept that as well. And you can see it's calculating all those operations and creating the toolpath for that as well. Now let's start with our tapped holes. Okay, so we'll go pick a tapped hole. I picked the countersink instead. So it just said please pick a tapped hole. All right, so we'll pick this tapped hole over here. And again, it'll choose the wizard together with the patterns that was used in that particular case. Okay, we'll go out over here. You can see that over there. We'll accept that. You can see the toolpaths were created over there for those. We'll go to the next one. Another set of tapped holes. Let's choose this time this set over here. We'll accept that one. And let's also accept, let's say this over here. So we have Hole Wizard Process tapped holes. Let's go to this one over here. We'll choose this one. No, it'll pick that entire set. Okay, and let's still go also to these here as well. So take those tapped holes. We'll click on that one over there. Accept it. And we still have our countersink hole that we need to do over here, as well as the simple hole. So we'll go now to a hole wizard, choose our countersink hole, click on it. Obviously, if I pick the wrong one in Service Pack 3, it'll let me know. And our last one is this simple hole that we have over here. Grabs all the information, creates the operations, and you can see we have all of these operations over here simply by choosing the whole wizard process. And it'll done actually very quickly. Now, what we should note also is that this entire process, every single one of these operations are just like any operation that you create manually. So if I want to make any changes to any of these operations, I can just go double click and edit the operation and make any kind of changes I need. If I want to change the tool, if I want to change my data over here, if I want to change my technology, anything I want to do. For instance, in this particular technology, I'm using a PEC drill. No, sorry, I'm not using a PEC drill. I am using G82, which is a regular drill, but it has a dwell time when it gets to the bottom. And it has my dwell time data over here. If I want to change that, I can change it, no problem. Okay. Now that we've mentioned all of these, what happens if I change the machine? Well, what do I mean by change the machine? Right now, I worked on this particular machine over there, and now I want to change it to a different controller. Now, what are the problems that are going to come into hand over here? Different controllers not every controller has the same cycle types. For example, you may have a Fanuc that has a G81 and a G82 and a G83, and you may go to a different machine that it may have a G81, G82, G83, but what you can do in that G83 is they have a little more flexibility. They have G83 where you can go up all the way, go to your clearance level or go all the way down, keep it down. There are all different possibilities. So not every single controller is the same. Okay, so when I change machines, the process that I'm using now for this particular hole wizard is not correct. Because this particular hole wizard process is made specifically for this processor, for this VMID over here. Okay? So what we have to do, in other words, is we have to make some changes. Okay? Let's take a look at what kind of changes are going to come about. Okay. And we'll do this also the correct way. Now, what I'm going to do over here first is to delete these operations. Okay, I've deleted them. And I'll also go over here and clean my CAM part by removing all unused geometries and all unused tools. Okay, as you can see over here, right now I only have two tools over there, which is for my face mill and my eye machining. Okay. Now I'm going to go back over here and change my machine. And this time I'm going to use a machine. I'm going to use a, let me see something really good. I'm going to use this Herco VMX 30U5X. Okay? I'll use that. I'll accept it and continue. Now, if I were to open up this VMID, you'll note my working style. If I go to General, there is no hole wizard process that I have for this. So right now, it's going to use the default, which is the one I used before, which is not correct. So if I were to use it, let's see what happens if I were to use it. Okay? Let me go ahead and I'll go again, just to do it on one of them over here. Let's go to a counterbore hole, and I will click on that particular hole over there. Okay, it'll recognize it. Process counterbore is incompatible with the CAM part machine due to the absence of cycles of G83. Okay, it'll proceed with the cycle G81. Okay, it'll do everything, but then I have to go ahead and start making changes over here. Okay? So my geometries are picked. My profiles, my profile operations are okay, fine, but I have to make changes in here. Now, the only thing I really have to do to make changes is go into my technology. So I go into my technology. In this particular case, this one here is fine. Not a problem at all. Okay, I can leave that. If I were to go into this drilling operation over here, my technology, sorry, that's not the drilling operation. I meant this one over here. That was my profile operation. It has a G83. In this particular case, this one worked out well. Okay? It has a pecking distance. Everything was done fine. If I were to do a this one over here, technology, again, it has a dwell. In this particular case, it worked out okay. Okay, but they're not always compatible. Let me do it again for my tapped holes over here. Okay, so let me do this particular tapped hole over here. I'll click on that. Again, it noticed that the cycles were a little different. So this one should be the same. It shouldn't be a problem at all. G82, that's correct. The next one, I wanted a G83. Let me see what I have over here. In this particular case, it gave me a G83. And the last one over here, this was supposed to be a tapped hole, but it gave me something else completely. Okay, so they're not always compatible. So I can go ahead and change it to my G84, but it doesn't always work that way, or recreate it. What can I do to stop this from happening? So first, let's delete all that I've done over here. And what I'd like to also mention is that what I'm going to show you is a little more technical. And if you need help later on from your support team, don't hesitate to call your support team as well. They can help you with this very well. But they're actually very, very simple. Well, like I said in the very beginning, my whole wizard process is based on a machining process. So let's open up the machining process. I'll go to open, and it happens to be based on this process over here called whole process metric G milling 3X. Okay, I'm going to exit now, and you see it exists over here. Now, I do not want to make changes directly in this one. What I do want to do is make a copy of this. Okay, and in the copy, I'm going to make it specifically for this machine. So I'm going to do save as. I'm going to call this one, let's call it Herco Sydney. Okay, that's the name of this particular process. There we go. Okay, now we're going to load that one. We're going to open it, and we're going to go to, here we go, Herco Sydney. Now, as I said, the machines, each process is for a specific machine or a specific set of machines. Note in the process itself that I opened up over here, we have a button at the bottom that says Add Machine. If I were to click in it, you'll see that it has machines existing over here. G milling 3X, which was one of the ones that we had, which was the machine I was using before. Now, what I'm going to do is I'm going to delete all of these machines. Click on yes. And now I'll go and add a machine. When I add a machine, I can see all of the machines that I have in my process. In this particular case, I want to go to my Herco VMX30U5X. So I'm going to go to my Herco. VMX30U5X. I'll click on OK. And I'll click on also add similar. If there are other machines here that have a similar process, as you see the other one, the other Herco that I had over there, it'll be added here as well. And I'll click on OK. Now note, the moment I click on OK, it'll tell me the following, that the drill cycles that are incompatible with the selected VMID have been suppressed. Okay, do you want to continue? Yes. Okay, so first of all, this process is now specifically for that machine, but I still have to make it that the technologies are the ones I want. So what I have to do now, let's just take, for example, our tapped holes. If I were to double click on it right now, and now do not pay attention to any of the parameters now. Okay, stay away from the parameters. Okay, now in this particular case, our tool spot drill, that's fine. You see, has not been suppressed, so nothing has to be changed over here. But let's go into our tapping over here, and I'll do edit. If I go to my technology, you see it is now tapping. So this is fine. So there are no changes have to be done as far as my tapped operation. So we'll just go out of there. If I go into my counterbore operations, nothing is suppressed over here. That means everything will work fine. Countersink holes, same thing. And my simple holes, everything is fine. All I have to do is save and exit, and we now have a process for our Herco VMX. Now, as a machining process, I can use it directly as machining process, but if I want to use it for my whole wizard process, there's one more step I must do, and that's this. In my VMID, in my machine itself, as shown over here, I have to open it up, go to my working style, and click on General. You'll note my whole wizard is empty. Okay? So if I were to go into my whole wizard, I load the one I wanted to be part of. Herco Sydney, and then we'll do save and exit. Okay? So now when I use the process, it'll use the process I created in the machining process itself. Now if I go to whole wizard, count the bore, click on my counter bore, accept it, everything works fine. Now the process I just did has to be done once, and then you always have it for that machine. Now again, this webinar is being recorded, so you can always go over exactly what I did over here. Okay? Now, let me go and actually load now a different machine where we will have a problem. Now, this machine was actually very easy. Nothing was suppressed. Everything went over pretty smoothly. What would happen now? Let me actually delete this. Okay? And go back into my CAM part, and this time load a different machine. I'm going to use one that's a little more, let's use my Hermila 5A. That I know is completely different controller. If I were to click on OK, continue, now I'll do the exact same thing I did last time. I can actually take this one because this is a copy of the original, and I'll do save as, and I'll call this one Sydney, HERM. That's enough. Okay, I'm going to load that one. Okay. Again, just like I did last time, add machines. I'll delete what I have here. See, if I go to add now, it won't show me any machine because it has to be machines that are similar to the ones that I have in here. But I can delete these. And now I can see my entire list. So I'll go to add. And I'm going to go to my Hermela 5A, which should be right over here. We'll accept that. We'll click on Add Similar. Let it run for a moment. You see it added 4 more machines. I'll click on OK. Again, I get this message. OK? We'll click on Yes. Now let's open the tapped hole. You'll note that these operations now are suppressed because they did not fit in to the cycles that I had before. Okay? If I were to use this machining process, I would get this over here, but the operations will be suppressed. And I can make the changes over here, but let's do it over here now. So first of all, I'm going to take this one, unsuppress it, and let's open it up. Edit. And the only thing I have to do is go to my technology and change my technology. In this particular case, I'm just going to go to my data. I have a dwell at my depth. So I'm going to change my dwell depth to have the parameter that I created. If I go to user-defined parameters, you'll note that we have parameters here for every single type. For instance, this is a tap spot drill as shown over here. So we have here parameters for our spot drill. I'm looking for a parameter spot drill dwell. Okay? That's all you have to do. And accept it. I'll go to my second one, unsuppress that as well. I'm going to open it up again. And again, go directly to my technology. In this particular technology, we have a step down. Okay, so I'm going to go over here and choose my user-defined parameters. We're talking about now the tap drilling. So let's go to the tap drill, peck depth. That's for my step down. And I'll click on OK. For my last one, the actual tap itself, again, I'll unsuppress that. Go to Edit. And my technology, I'm going to change this to my tapping operation. And that's all I really need to do here. Okay, let's save and exit. Save and exit. Now, obviously, let me go back into here again. I would have to do the same for my counter boreholes. Okay, again, all of the drilling operations, I will have to unsuppress and change the technology. Now, you do this once, but once you do it, it's set for that particular machine. Okay? Now, let me just do save and exit for a moment. And now, remember, I have to tie this one to my machine. So I'll double-click here, go to my working style, and in my general field over here, I'm going to tie this to Herco, sorry, not Herco Sydney, but Sydney, H-E-R-M. That's all set. Save and exit. And we're ready to start working. So now if I were to go to my hole wizard process, go to my tapped hole, the one I actually did fix, and click on this tapped hole over here. You'll note that it was created without any kind of notifications. You'll note none of them are suppressed because I unsuppressed them in my process. And if I go into, let's say, the last one over here, you'll see that my technology is set for tapping. This one over here, technology If I go to my data, you can see there's actual value for my step down over there. Okay, so what we've seen here basically is how we handle the machining, the whole wizard process, because this is based on a machining process. Now, if you want to create a new whole wizard process, my advice is very simple. Take the process that we have and copy it. Don't create a new one, copy it. Because there are certain things that are very important inside the machining process for the whole wizard process. And you may not know this. For example, if I were to open up the process itself, first of all, you'll note that they are in a specific order over here, and nothing is added on over here. Now we're working on the option of doing copies and making more in here itself. But right now we have these 4 over here, and these 4 should be edited if you need to be. Now let me just go into one of them and show you exactly what I'm talking about. For example, if I go into tapped holes, there are certain parameters that we inside the process automatically take care of that we've done already. For instance, you'll note that if I use it, I did not have to choose my upper level. My upper level was automatically put in here inside my machining process because we have a parameter. You notice where it says pick upper plane. I didn't have to pick it. I have a parameter that deals with it for me. Let's open this up. In this particular case, it was a condition. And it said, okay, look for a countersink diameter. If the one exists, I'm just going to go through it very quickly, then use the Z level of where that countersink diameter upper is. So these are parameters that we get from SolidWorks, but you have to know to be able to use them. Okay? So what I always suggest with these kind of processes, specifically for the whole wizard process, make a copy and follow the rules. Whenever you see parameters, there are conditions. For example, you see here we have if. Those conditions are there, so it picks the proper depth, it picks the proper diameter, it picks the proper upper level. All of those are used within those conditions. For example, you see we have here spot drill chamfer diameter. Okay? Now, what if it doesn't have a chamfer diameter? There are spot drills. In other words, there are holes sometimes that are tapped that don't have a chamfer on top. I've seen them created. People have created them without a chamfer on top. Well, it'll never find a chamfer. So I have to give it a condition to say what happens if I don't find one. Okay? We have to take into consideration, like I showed you before, the upper plane. If I have, for instance, here we go, tap drill diameter. Okay? Tap drill diameter. Let me just open up the condition that I have over here. Well, what we get when we have a tap drill in SolidWorks, it shows us 2 different things. It shows us a tap drill diameter and it shows us a through tap drill diameter. Okay? A through tap drill diameter is for a hole that's through. A tap drill diameter is for a hole that's blind. That's what SolidWorks gives us. So in this particular case, I said, okay, if there is a through hole diameter, in other words, there is if there is no through hole diameter, that means it has a tap drill diameter. How do you know that there's no through hole diameter? If it's equal to 0. If it's equal to 0, that means anything that does not exist, any of these parameters that do not exist on that hole has a value of 0. So I tell it, okay, then use the tap drill diameter because that does exist. Otherwise, if it's not equal to 0, in other words, it does have a value, then use the parameter for the through hole tap drill diameter. Okay? Now, let me just do one more thing. Then we'll leave it open for questions. And I'll just show you exactly how you can see those parameters as well. Let's go back in here again. And again, I'll click on a tapped hole. I'll click on this tapped hole over here. Now, remember I mentioned to you before about the dump file? Let's open up a dump file here. You'll note it's a tap blind. Okay. Now, let's take a look. Now, you'll note through hole diameter, this is not a simple hole. This is for a tapped hole. It does not exist, so it's 0. Let's see where we have values. Okay, we have tap drill diameter has a value to it. If I were to look for through tap drill diameter, it's 0. In other words, this is how we know it's a blind hole. Because if this was a through hole, this would have the value at 6.8, and this would have a 0 value. So any parameter that does not exist on that hole, these are the list of parameters from SolidWorks, they have a value of 0. And we've used these names in our SolidCAM hole wizard parameters as well. So that's how you know whether one is one way or the other way if it has a 0 value. In other words, whatever exists has a value. If it doesn't exist, it has a 0 value. It's a blind hole, so it has a drill angle at the bottom. If it was a through hole, this value would be 0. Okay? Now, making any changes, again, if you need help making changes or having it specified specifically for your particular machine and you have problems doing it, one, you can go back to the recording of this particular webinar that I'm doing now, and you can always use your support team. They'll be more than happy to help you out with this. Now, let me just point out one more thing that I had mentioned before. The fact that I'm working right now in Service Pack 3. You'll note that in Service Pack 3, every single time I create an operation, I automatically see the tool path on the part itself. That's because, let me actually get rid of them. That's because if I go into my CAM settings, we've added in our toolpath simulation a tab for simulation modes. In other words, we have here preview tool path after calculation. And note all of these are showing. So, for example, if I were to get rid of anything in 2.5D milling, I'll click on that. And now do the process for the tapped hole. Click on OK. Actually, it did show it because I clicked the wrong thing. But it will not show any of these operations over here. I can do that at the Iron Machining 3D as well. It will not show them clicked off over there. Okay, that's basically it for the webinar. I just also want to remind everyone, Hole Wizard process is specifically for holes that were created using SolidWorks Hole Wizard. That is where this works. Okay, thank you very much for joining the webinar. This webinar, as I said, has been recorded, and you will be able to see it, I believe tomorrow already be on our website. If you were to go into our website of SolidCAM, we have a section here called webinar recordings, and you'll see it as the latest webinars over here. And again, also, you can see all of the webinars that were recorded over here that we've done in the past. Okay, everyone, take care, have a great day, and we'll see you at our next webinar.